No solve the reviews. In this video, I'm going to discuss about the area and volume of cube and cuboid. I start with the one diagram of cuboid over here. Okay, so we are making one cuboid. Okay, so I made sorry, one diagram of cuboid. So this one down, right? This we call here length, is it? And this one we call this breadth, is it? Which is the longer one that we call length, and which is shorter one we call it breadth on the base, right? And then which is vertical one that we call here height. So in this cuboid, these three dimensions exist, or we may see in our room also, is it? If it's not a square room, then one side on the base is longer, it's on floor, and one side is shorter. So longer one we call it length, and the shorter one we call it breadth, and which one is the vertical that we call it height, is it? So these are the three dimensions. And after knowing these three dimensions of the cuboid, right, now we are going to see here how many faces exist, is it? So the very first face is this down, is it, which we call base, right? Or you can call this floor in the room also, is it? So base or floor, is it? And above here is the another face, is it, which is above here, is it? So that we call here ceiling, is it? So both are the rectangular faces, is it? Ceiling and the floor, is it? Both are in the rectangular shape. So two faces are these, is it? And if we're sitting inside the room, we can see there are obviously four walls, is it? So there are four walls over here, right? So total there four walls and base or floor and then ceiling together there exists total six faces in the cuboid, right? Now we're going to talk about this area, right? So of any rectangle, right? So we know about area of rectangle is given as a product of their sides, right? Or we may say their length and breadth, length and the breadth, is it? And now for the floor, is it? So what we get as the area of floor over here is its two sides on the floor are length and breadth, is it? Length into breadth. So if we do, we get the area of the floor. And for ceiling also same, is it? So if we see in the ceiling, so the two dimensions are length and the breadth. So area of ceiling, so it's also the same, is it? It's length into breadth. And shortly we write L into B, length for L and breadth for B, right? And then now let's see through the wall, is it, which is along the length, right? So let's see up the wall for here. Okay, so this wall which is the along the length, right? So okay, I painted here with green, right, for this wall, which is the wall along the length. So it's two dimensions. Let's talk about this two dimensions. So one dimension is length, is it? Here this one dimension which is length, and another dimension is this which is height, right? So here another dimension is height for the wall along the length. So it's also rectangle, and when we find its area, it's two dimensions we have to multiply. So length and height we have to multiply, right? So when we talk about the area of wall, right, along the length. So its area will become here length into height, and such wall exists at back wall also, at back side also. So L into H, that exists at back side also. So if we add this LH plus LH, we get area of two walls along the length. And now let's talk about the area of wall along the breadth, right? So I see this as the this is the area wall which is along the breadth, is it? So I've painted here. Okay, so this is the wall which is along the breadth, is it? So this is the breadth over here. So this is the wall along the breadth, and its two sides, or its two dimensions of the wall, are breadth and the height. So their product will give us the area of the wall along the breadth, is it? So now another wall is there, whose area is B into H, is it? So it's wall along the breadth, and the same wall exists on the opposite side of this wall also. So that's area also B into H. So this way we get the area of four walls of the room, right? So area of four walls of room, or this is called curved surface area of the cuboid, right? Curve, or we can call it, okay, this curve or lateral, right? So curve or lateral surface area of cuboid. So the thing is same, so which we are going to get the LS for 2 times, is it? These two LS we get added, so we get there 2 times LH, and the BH, so these two we get added, is it? So 2 times BH, and we see here 2 and H are common, is it? So 2 and this H, here also 2 and H, so common, so we get there 2H and bracket L plus B. Alright, so this is the curved or lateral surface area of the cuboid, or it's the four walls of the area of the four walls of the room. And now if we include this area along with the floor and ceiling, so we get the total surface area of the room, or we get the total surface area of the cuboid. Right? So now go for the total surface area of cuboid. Total surface area of cuboid. So how much you're going to get? See, so area of the walls along the length are 2LH plus 2BH, is it? And area of the floor and the ceiling, so both are having same area, L into B, so 2LB, is it? So that will give you 2 common, LH plus BH plus LB. So this is the total surface area of the cuboid, or total surface area of the room. Now we start with the exercise. Alright. So I'll make this clear first. I'm keeping the diagram here. Okay. Now number 1. Right? Okay, so here with the let's see the question first. What is given? Observe the following objects and find the total surface area of the following rectangular solids. So the solid is given here, cuboid. So total surface area we are asked to find here. I'm going with number B, right? So in this number B, when we find total surface area of solid or cuboid, so formula we have already known, it's 2 times LB plus LH plus BH, and the values, so length is here 6 centimeter, breadth is here 2 and height is here 4, right? So let's keep the values. So length is 6, breadth is 2, again length is 6, height is 4, and breadth is here 2 and height is 4, is it? So let's calculate. 6 to 12, 6 4 24, 2 4 8. So 12 8 20, 20 plus 24, so that we get there 44, so will become here 88. So total surface area of the cuboid is 88 centimeters square, and this number B. So A and C, you can do it yourself. Alright, and I'll go with number 2. So make this clear. Okay, so let's go with number 2 here. Okay, so we are here asked in number 2 to find the total surface area of the following cubes. Right, so of the cube we haven't discussed, right? So let's identify the formula for first. So in cube, so there are 6 faces in total, and all 6 faces are the squares, is it? So here area of one face of cube, area of one face, or you may say each face. So like I say each face, area of each face of cube, so that is L into B. When you do L into L, you get, is it? So length, breadth, height, all three are same in cube, so all three you can denote by L. So L into B, instead of that we say here L into L, and we get the L square. So area of each face of cube is L square, and when we find total surface area, there are 6 faces in total, so total surface area will become a 6L square. So here total surface area of cube is equal to 6L square. So by using the same thing, now I do for this number B. So here length is given 3, so 3 square, and be very sure that you won't make mistakes. 6 into 3, 18 you shouldn't do, because square you have to operate first. So 3 square is 9, so 9 6 54. So total surface area of this cube is 54 centimeter square, and same way you can do for A and C. Now moving with number 3. So I make this clear. Okay, number 3 now. So here let's say it's C. Find the total surface area of the cuboid with following length, breadth and height. Alright, so this is the very same which we just did in the number 1, is it? So here given here serially length, breadth and height. Length is given 15, breadth is given 12, and height is given here 11. All are in the centimeter unit. So you'll be finding same formula which we just did in number 1 to find the total surface area of the cuboid, is it? So I'm withdrawing it to do. Now moving to number 4. So make it clear. Okay, let's see in number 4 what is there. Okay, so here we are asked to find the surface area of the cube of the following length. Is it? So here length of the cube is given 14 centimeter. So total surface area of cube, total surface area of cube, so that equal to 6L square. So 6 into 14 square you have to do. So 6 into 14 square when you do, so be very sure 6 into 14 you won't do first, is it? So 14 into 14 square, you get there 196, is it? So that you get there 196 and make calculation, actual multiplication you do. So 6 times you get there 1176 centimeter square, and which is the total surface area of the cube, right? So I did number 4. Now we go to number 5, right? So let's clear this. Okay, number 5 now. Okay, let's see what's here in number 5. Okay, I'm going with number 5A, right? What's the idea? See, so surface area of cuboid is given, and beside of that length and breadth are given, and we are asked to find the height, right? So here given surface area, length is given 12 and breadth is given 9, and you're asked to find the height, is it? So that given total surface area, from that I start here. So total surface area, is it? Total surface area of cuboid, so that's given here 636 centimeter square unit. I'm not writing right now, and its formula is, we have already used 2 times LB plus LH plus BH, is it? That equal to 636 we are given, and we are about to solve it, so let's use the word R, is it? And this 2, let's bring down for dividing first, is it? And now let's keep the values which were given. Alright, so length is given 12. In place of length we can keep here 12, and the breadth also given, that's given there 9, is it? And length again keep 12, and height is not given, that we have to find, so let's keep same. And breadth given 9, 9 into h, is it? Now 12 9, 9 to 18, 9 on 9 10, so 12 900, right? So these are 12h and 9h, so they will get added, so you get that 21h. And when you divide 636 by 2, 2 3 is 6, 2 1 is 2, and 2 8 is 16, is it? So or 21h. To solve h, now this 108 let's send to the right side, so 28 minus 108 you can say, so 21. Okay, so 21h, the scaling there, 318 minus 108, so 300 minus 100, 200, 18 minus 8 is 10, so it's 210. Now 21 getting multiplied with h, so that will go down for dividing, so h equal to 210 divided by 21, so that equal to 10. Therefore height of the cuboid, height of the cuboid, that is equal to 10 centimeter. Done, is it? So A I did, so B is very same with A, you can do it yourself. Alright, now moving to number 6. Okay, so what's there in 6, let's see. Very similar number you do have in 6, right? I'm going to number B, right? So what's it? If the area of the cuboid is 888 centimeters square, so that's total surface area, and their length and height are given. Length given 16, height given 12, and you're asked to find your breadth of the cuboid, is it? So very same as number 5. This one I'll do here. So area of cuboid, or surface area of cuboid, or total surface area of cuboid. So I say here TS, right? Total surface area of cuboid, and that we are given here 888 centimeters square, is it? Okay, And now this formula we keep 2 times LB plus LH plus BH, that equal to here 888. Now or we have to use here. Now this 2 will go down for dividing with 888, is it? And now other values escape. Breadth, length and height were given. Length given 16, height given 12, is it? So in place of length we can keep here 16 into breadth that we need to find. Length again keep 16 and height we are given 12. And then breadth we need to find and height given 12 is cube. Now these two, is it? So these two 16b and 12b, these are the like terms, so we get them added, is it? So you get there 28 times breadth, is it? And 12 into 16, is it? So 12 6 72, is it? And 12 1 12, 12 7 19, so 192, and that equal to 444. So by dividing 8 by 2 we get there 444, is it? And now we do what? So this 192 we send to the another side for subtracting, and we get there 28b, is it? And that's subtracting, let's do here on the rough side. 422, is it? So 14, is it? 1 you take care of 14 minus 9 5, is it? And for that remain 331 is 2, is it? So 28b equal to 252, is it? And now b equal to, is it, 252 divided by 28, is it? Now let's do it in rough to calculate this, is it? So first these you can count with 4, is it? So 4 6 is 24 and 4 3 is 12 and 4 7 is 28, sorry. Okay, and now by 7 they can cut, is it? So 7 1 is 7, 7 9 is 63, so that we get there 9 centimeters. So breadth of the cuboid is 9 centimeter, right? So I made it clear with number 6. Now I move into the number 7. So before that, let's make this clear. Number 7. Okay, so what's here in 7? Let's see. They're also very similar number with number 6, right? So here we are given area of the cuboid, is it? And breadth and height are given, and we are asked to find here height, like find the length. So a number I'm doing. So here total surface area of cuboid that we are given here 537 centimeter square, is it? And next we are given here well of breadth 8 centimeter and height we are given here 11 centimeter, and we are asked to find its length, is it? So let's keep this formula. So total surface area of cuboid 2 times LB plus LH plus BH, let's keep, that is equal to 537 here. And then now keep the values, is it? So LB, is it? So breadth and height given, length is not given, and breadth given here 8, length not given, height is given here 11, and breadth into height, so breadth 8 and height 11, and that equal to 537, is it? And now you may bring this 2 down also for dividing, or you just open it, right? So I go with that opening. So L 8 times L, these two let's get added. 8 times L and 11 times L, let's get added. You get there 11 8 19 L, is it? So add it 19 L, and this is 88, and that equal to 537, is it? and after that let's get open by 2. So 2 into 19, 38 you get, so 38L, and 2 into 88, 2 8 is 16, 2 8 is 16, 17, so equal to 537. So or 38L equal to 537 minus 176. So 30L equal to, okay, what what do you get there? Let's do it in raw. 537 minus 176, is it? So 76 subtracted 1, and from 3, is it? From 3 we subtract 7, we can't do, so 1 take carry over. 13 minus 7, you get there 6, is it? So there remains 4, 4 minus 1, 3, is it? So we get there 361, is it? And now L is equal to over here 361 divided by 38, is it? And now we need to convert either into the decimal number or the mixed fraction, right? So let's convert into either of one. So let's divide here, right? So by 38, let's get 361 divided, is it? So 38, how many times it will go? You have to use it, is it? So when you divide, it goes for 9 times, right? So 9 is 72, is it? 9 3 27, 27 and 7 34, is it? And now subtract 11 2 9 and 5 4 1, is it? So it's 39, 9 whole number, 19 by 38, is it? 9 whole number, 19 by 38. And the thing is what, 19 and 38 you can cancel, so 2 times. So here 9 whole number, 1 by 2 centimeter, or you may say is this is 9.5 centimeter. So it's a 7 number to find the length when total surface area and its breadth and height were given, right? Now I go with number 8. So let's make clear of this first. Okay, number 8 we are going. So what's here in 8, let's see. Okay, see what's the idea? If area of cube, area mean here total surface area, is it? So total surface area of cube is given 294 centimeter square, and we are asked to find its length, is it? So here we are given, I'm doing it number 8, right? So total surface area of cube, so this we are given 294 centimeter square, and we know its formula is 6L square, so that equal to 294 here. And now I use here R, so L square equal to 6 getting multiplied with L square, so it will go down for dividing, 294 by 6. So L square equal to, so 6 by 6, 294, 6 4s are 24, so 5 5 4 54, so 6 9s are 54. So L square equal to 49 we got, and 49 is square number, which is square of 7, is it? So as squares are equal, their bases will be equal, so therefore we get here L equal to 7. So that is the length of the cube, right? And same way you can do number B yourself. Now go with number 9. Okay, so number 9, let's see what is here. Okay, 9 is one long question, right? Let's understand the question here, what is said. So in the figure, a cuboid with length, breadth and height. So length, breadth, height, all three things are given here. Okay? So length given 6, breadth given 3 and height given 4. Now you're asked to write the formula to find the total surface area, so that you can write and find the total surface area of the box. So earlier what we have used isn't 2 times LB plus LH plus BH. You'll be using that and you'll be finding the surface area of this box. And number C, what's here? How much more is total surface area of cuboid than area of base? So here area of base is area of the floor, that is LB, is it? So you can find it. You find area of floor by using L into B. And now what you have to do here is you have to find the difference, because it said here how much more is total surface area compared to its base, is it? So that which you have found area of the total surface of that cuboid and area of its base, get the difference, and that difference, for that difference you'll say that total surface area is this much more than the area of the base. Like, and in number D now, is there any difference in the total surface area where it's open or closed at the top? So it's really different. So total surface area, when we calculate, there will be calculation of the total area of the 6 faces, is it? But when top will be open, if this, like if ceiling is not given here, is it? So just 5 faces will be counted, so 4 walls and floor, is it? So that is the surface area of the total surface area of the uh, open at the top, right? So it will differ by the area of the L into B, or area of the base. How much area of the base, or how much area of the floor is there, or area of the ceiling is there. So that area will be the difference between the total surface area of cuboid and the surface area of cuboid with the open top, right? Okay, so you can justify like that. Now so up to here, number 9, right? By doing, we get ended the area, is it? And now we are going with the volume of the start of the exercise 9.3. So to go before that, I make this 9 number clear here. Okay, so we going start with the that of the volume of cuboid, right? So it's of the same topic and easier one. Okay, so number 1, right? So it's ADSC. Number 1, B number I'm doing, right? Find the volume of the following objects in the shape of the cuboid. So we have already known volume of cuboid. Volume of cuboid is L into B into H. These 3 dimensions of the cuboid are L, B and H. So their product, what we do, right? That will give us the volume of the cuboid. So here length is 10. So in place of length we keep 10. And breadth is there 4 and height is there 6, is it? So I'm just keeping number. Actually these are what? 10 centimeter, 4 centimeter and 6 centimeter. So centimeter, centimeter, centimeter 3 times multiplied, so you'll get the unit of the volume as centimeter cube, right? So here 6, 4, 24, 24 and 10, 240. So 240 centimeter cube will be the volume of this cuboid in number B. And same like you can do rest numbers A, C and D, right? So this number 1 is clear. Now to go into the number 2, I make this clear. So now I'm going with number 2. Okay, so here also same. Find the volume of cuboid if here length is 15, breadth is 12, height is 8. So thing is very same. These 3 dimensions, length, breadth and height, you have to multiply to get the volume of the cuboid, is it? So it's up to you. You can do it yourself. So now I'm going with number 3. So here say find the volume of the cubes of given length. So with A number I'm going. So here volume of cube, right? So when you find volume of cube, we already know cube has all three dimensions with the same length, right? So L into B into H. Instead of saying that, you can say what? L into L, and that will give you L cube, is it? So here length of the cube is given 6 centimeter. So 6 centimeter whole cube when you do, so 6 cube is 6 multiplying 3 times, and centimeter cube means centimeter cube is here, so it's what, 6 into 36 centimeter cube. So 6 6 36 6 3 18, 18 and 3 21. So 216 centimeter cube we get as the volume of the cube, and this number A, right? And B and C you can do yourself, right? So I'm going with number 4 now. So I make it, I'll make this one clear first. Okay, so number 4. Okay, so in this number 4, let's say DC, find the length of the side of the cube having the following volumes. So volume of the cube is provided here, and you are asked to find the length of it, is it? So same rule we'll use here. Volume of cube that we are given here 2197 centimeter cube, alright, and we have to find its length. So volume of cube, its formula is L cube that we keep 2197, is it? And to find a length, now we have to here factorize 21 and 97. So let's do it in rough side, alright. Okay, so but what they are divisible, let's see, is it? So 3 by 3 is not divisible. 3 7 is 21, 3 3 is 9, and at 7 there remains, is it? So not by 3. Now let's check by 7. 7 3 is 21, is it? And then for 9, 7 1 is 7, so 2 remains, 2 7 27. So by 7 27 also, sorry, okay, 7 3 21, and 7 1 is 7, so remains there 27, not getting, is it? So I'm not getting sure how much is this right now, so I'm taking help of the calculator for now. So how much will be, let's see, 2197 we do, so it's of 13, right? So you need to know the table of 13. Okay, so by 13 it goes, is it? So 13 31 is 13, is it? And then after 13, is it? So 13 7 remaining, 7 1 8, is it? So 89, so 89 is there, is it? So 13, how many is 89? It goes, it is 6 and then 9, alright. So now 13 into 13 is 169, alright. So it gives what? L cube equal to here 13 into 13 into 13, so we get there 13 cube, is it? So this way we get there. As powers are same, we say here L equal to 13. So the thing is what? Length of the cube, or length of the side, each side of the cube is 13 centimeter. Length of the side of the cube is equal to 13 centimeter, alright. So I made it clear with number 4. B and C you can do, you try yourself, right? So I make clear to do for number 5. Okay, now number 5 I'm going. Okay, so what's said here in number 5, let's see. Okay, so I go with this A number, like, so how much water in liter is there in a in an underground water tank with dimensions mean length, breadth and height serially. So 3 meter, 2.5 meter and 1.5 meter, these are length, breadth and height. And here said use 1 meter cube is equal to 1000 liter. We need to know it. Alright, 1 meter cube, which space is there, it can hold 1000 liter of water. Alright, so by using this thing we have to identify how many liters could this tank hold. Alright, so before that we have to find its volume. So volume of tank, let's find first. Volume of tank, L into B into H we do. Sorry, 3 meter, 2.5 meter and 1.5 meter, is it? So here 25, 2.5 and 3, 7.5 into 1.5 and meter cube will be there. So 7.5 into 1.5, let's do it in rough. So 5 5 25, 5 7 35, so 37 and 75. So 5 7 5 12, 7 3 10, 10, so 11, is it? And after decimal there are 2 digits, is it? One this and one this, is it? So after decimal 2 digits should be there, so here we have to keep point, is it? So it's what, 11.25 meter cube, is it? And thing is what here, 1 meter cube can hold 1000 liter. Then 1 meter cube equal to 1000 liter, it is said. So 11.25 meter cube equal to 1000 into 11.25 liters will be here, is it? So it's 11,000, is it? 1000 into 11, 11,000, so 11,2500, 11,250, sorry. So 11,250 liters. So this many liters of water could be kept in that underground tank, which is in the cube shape with given length, breadth and height. So same way you can do for number B yourself. Alright, so now I go with number 6. Okay, so what's here in number 6? Let's see. So in here number 6 we are given volume and one dimension is missing here, so length of that dimension we have to find here, is it? So I go with number B. Like, just drink water for a bit. Okay. So number B, is it? So you're given volume of the cuboidal tank, like 540 centimeter cube, and their length and breadth, length 9 and breadth 5 centimeter given, is it? So volume of cuboid, that's given here 540 centimeter cube, is it? And it's the product of length, breadth and height, that's 540, and length is given 9, breadth is given 5, and you have to find your height. So 9 5s, is it? So 45 we get, is it? Let's not do this product, is it? Let's go cancellation by bringing on the right side for this 9 and 5. Okay. How many times it goes? Let's see. 9 6, is it? 60. So we get their height equal to here 60 by 5. So 5 12 is 60. Therefore, height of the cuboid is 12 centimeter. So A, the sign made it clear. A and C, you can try yourself. Alright. So for the next number, going for the next number, I make this clear here. Okay, so number 7. So here one diagram is given, and let's say DSC number A, right? So find the length of rectangular box if its volume, breadth and height they are given serially. So it's very same as number 6, right? So here you are given volume, given breadth and height is given, is it? So length you have to find. So things very same, is it? So volume you are given, is it, 32, 40, and its perk of length, breadth and height, their dimensions, is it? And breadth and height are given. So breadth is given 12, height is given 15, is it? So bring 12 and 15 down for dividing, then you get the length. So very same way, 6 how we have done is here, is it? So B also same and C also same. So it's clear with number 7. You can do it yourself. Now let's see what's there in number 8, right? Okay, I'll make this clear. Okay, number 8 now. So here 8 also going to be very same as number 7. Okay, let's just see. So find the volume of the rectangular container, is it, with the height 9 feet and base area 1 feet square, right? So bit different, right? But you find more easier than previous one, right? So here we have to, okay, let's provide here what we are given here, right? I'm doing it number 8 here. Base area, or you may say area floor, but this is box, so this base we say. So base area, is it, base area of the container, that is given here 150 feet square, and its height is given, and its height is given here 9 feet, is it? And we are asked to volume, we are asked to find the volume of the container, is it? Then volume of container, so that equal to, we have already known it is L into B into S. And thing what over here is, this L into B is the area of the base. If it's room, if it's about the room, it is area of the floor, is it? And now it's about the area of the container, cuboidal container. So L into B, that will give us area of the base. So in place of L into B, you can keep here, or you can write here area of base, and into height. And now area of base we are given here 150, is it? And height we are given here 9. So easily we find, is it? So 9 5 45 and 9 1 9 4 13. So 1350 feet cube, is it? So that is the volume of the container. And same is for B, is it? Find the volume of rectangular A4 paper box with height 12 centimeter and base area 36. So you can try yourself, is it? Now 8 I made it clear. I'm going with number 9. So let's make this clear first. Okay, so what's showing number 9? Let's see. Number AIC. The volume of cube with volume 1728 centimeter cube, is it? And its volume is same with the volume of cuboid, and base area of the cuboid is 288 centimeter square. Then find the height of the cuboid, is it? So here thing what is said is volume of cube and the volume of the cuboid, is it? Volume is same as the volume of the cuboid. So this thing is said here, right? So thing is what here? Volume of cube, is it? So that given equal with the volume of cuboid, is it? Thing is this, right? And for that Here volume of the cube with volume 1728 centimeter cube. So volume of cube is already given 1728 centimeter cube, and for the volume of the cuboid, here base area of the cuboid is given 288 centimeters square, right? So its base area of the cuboid is given. So as we did in number 8, volume of the cuboid, you can say base area into height. Is it? So here base area is given, just we need to find the height of the cuboid. So in place of base area we keep here 288, and height of cuboid we need to find here. So it's 1728 on the left side, same, is it? And now to find the height of the cuboid, we bring this 288 down for dividing, is it? So equal to height, is it? And now to make calculation, so let's do it in rough over here, is it? So by what you get divided, is it? Let's see. I guess it's divisible by 4. Let's go with 4. 4 7s are 4 2s, is it? 4 4s is 16. 4 3 12. 4 2s, is it? And now by 8 they are divisible. 8 9s is 72, is it? 8 5s are 40. 8 4s, is it? And then 54 by 9 we get, so now 9 6, is it? So 6 we got, so 6 equal to height. So the thing is what, therefore height of the cuboid is equal to here 6 centimeter, is it? So same way you can do B number, same thing is there. Volume of the cuboid is double of the cube. There in this A number, these were equal, and in the second number, volume of cuboid equal to say 2 times of the volume of cube, and thing is very same. Height and length of the cuboid are given, is it? And breadth of the cuboid you have to find. So cube of the cube side is given 6 centimeter, so volume of cube you will be finding by using 6L cube, so 6 cube, and double of that you will be doing, and that will be the volume of the cuboid, and you break it in LBH, and the length and height given, so breadth you can find, is it? So you try it by yourself, is it? Now the last one, number 10. So before going that, so let's make this clear. Okay, so going with number 10, right? Okay, what's here? Let's see. Here given a diagram, right? A cube having length 5 centimeter and cuboid having length 15 centimeter, breadth 5 centimeter, and height 5 centimeter respectively is given in the figure, is it? So one cuboid given, one cube is given, is it? Now first number would say write the formula to find surface area of cubes. So we know it's already 6L square, and find the volume of cuboid, so that you do by using L into B into S, so it will be product of 15 5 and 5, right? And then find the total surface area of cube. This we do as 6L square, so 6 into 5 square you can calculate it. And the number was said here, how much greater the surface area of the cuboid than the surface area of the cube. So you will be finding, you'll be calculating these things, is it? Sorry, not the here. How much greater the surface area of cuboid. So surface area of the cuboid we are not asking ABC, so you have to find, is it? So formula you already know, you use that and find the surface area or total surface area of the cuboid, and that found area you should check by how much it's greater than the surface area of the cube. So surface area of the cube you have found here, is it? And you check by seeing the difference, and that you can give us the result for that, right? So up to 10 number for this topic I made it clear, is it? So you watched from beginning to end. Thank you for watching. Keep learning.